When we're graphing rational functions, we have to think of the factors. So the first thing we're going to do with this is we're going to factor this expression. So in the numerator, it's going to be easy to factor because there's no leading coefficient. We know that two numbers that multiply to 6 and add to negative 5 is going to be x minus 6, x plus 1. So there's my numerator expression. The denominator is going to factor into 2x, looks like minus 3, and x plus 1. Okay, this one looks pretty easy to guess. If we can't guess it, we're just going to put it in our grid. So at this point, I can see that I have some restrictions in the denominator, and those restrictions are going to give me asymptotes and holes. So I'm going to start with the asymptote. Okay, the asymptote is going to be from the factor that doesn't cancel, which is x minus 3. Sorry, 2x minus 3. So the vertical asymptote is at x positive 3 over 2. So we solve for the 0 in that denominator. So I'm just going to draw that in. So here's my graph here. I'm just going to use my ruler here, and I'm going to sketch in that vertical asymptote at positive 1 over, or sorry, positive 1.5. Okay, so there's my vertical asymptote. My hole is going to come from the factors that cancel. So these factors cancel. And so I'm going to have a restriction or hole at x equals negative 1. So when I draw that in, I need to have my vertical my hole at x equals negative 1. Okay, so I've got my vertical asymptote hole. I need my horizontal asymptote. The horizontal asymptotes are found as endpoint behavior. So what happens to the largest powers as x gets really, really big? Well, these parts become insignificantly small compared to x squared and 2x squared. I end up with a ratio of 1 over 2. So we write it formally like this. The limit as x gets really large, f of x tends towards positive 1/2. And that is my horizontal asymptote. So I'm going to draw in my horizontal asymptote here at positive 1/2. Now, horizontal asymptotes are what's happening way out at infinity. Okay? We don't worry about what's happening locally, but what's happening way out at infinity. Okay, so there's my vertical and horizontal asymptote. Okay, so then I'm just going to say my horizontal asymptote. Okay, is at positive 1/2. Okay, it's at y equals positive 1/2. So I need to find intercepts now. My y-intercept is when x is 0. So I'm just going to do a little table of values here. My table of values, I get x is 0. When I plug in x is 0 into this expression, I get negative 6 over negative 3. Well, that's going to be positive 2. So I end up with a point at positive 2. My y-intercept is when y is equal to 0, and that's when I find it. To find that, I look in the numerator. So I'm just going to do this here. Okay, so I need, in my numerator here, this numerator factor here, x minus 6, is what's going to give us our 0. So at x equals positive 6, we're going to have a 0, or a horizontal, an x-intercept. So there's my point. Okay, so I've shown all the points I need. At this point, I do need to know what this graph looks like. So I need to know that it follows the asymptote and has to go through the coordinates that I gave. So there's my coordinate here. It's got to follow the vertical asymptote down and then follow the horizontal asymptote out to infinity. Okay, so there's my graph. The hole I need to draw in at -1, my hole is going to be right about there. Okay, if I want to find the y coordinate of my hole, I just plug it into the simplified expression. So I plug it into here. I'm going to get -7 in the numerator, so -7 over. When I plug -1 into there, I get -5, so I get 7 over 5, or 1.4. So that coordinate, this coordinate here, is at -1, positive 7 over 5, or positive 1.4, and that represents the hole in the graph.